Okay, we went over the logarithm laws in class, and what we discovered was that the log of a product is the sum of the logs, which was expressed by this law right here, so that we could break them up. And the log of a quotient is the difference of the logs, and the log of a power is equal to the power times the log of the m raised to the 1. So let's take a look at problems on page 476. These are the ones that we had to express in terms of log m and log n, which meant they did not want them expressed as log m to the 6th n to the 3rd. So what you needed to do here was just to split these up. So you're going to use both of the laws, the power law and the sum law. The log of a quotient is the sum of the logs. So we're going to add log base 2 of m to log base 2 of n. But you have to take the exponents, 6 and 3, and bring them out in front and multiply them by the log. So that's how you do that one. In number 4, the first thing you have to do is you have to express this radical right here as in exponential form. So what I did was I took the whole quantity, m squared n, and the cubed root raises that whole thing to the 1/3 power. So it's the same thing as the log base 2 of this quantity raised to the 1/3. Then I brought the 1/3 because this whole mess in here, m squared n, the mess, being raised to the 1/3, you can bring this 1/3 out in front of the log. So you have 1/3 log base 2 of m squared n. Now you have to take and split these two up, but that's 2 times the log of m, log base 2 of m, because this is also a power. And then add to that the log base 2 of n. N was to the first, so you don't have to bring any number out here. And then that is equal to, all I did was multiply the 1/3 by the 2 and put the 1/3 in here to get rid of the parentheses, basically distribute your 1/3, so you get 2/3 log base 2 of m plus 1/3 log base 2 of n. Okay, in the next set of problems, they've given us two numerical values for the log base 10 of 9 and log base 10 of 2. I've put those in green and this orangey color up here, just so that you can see how they're substituted in. So you need to find the value of log base 10 of root 2 right here in problem number 11. So all I did first was take root 2 and write it in exponential form, which root 2 is 2 to the 1/2 power. Then I used the law of the powers law of logs and brought the 1/2 out front, multiplying it by the log base 10 of 2. Well, log base 10 of 2 was given to us as 0.30. So all I did was substitute in 0.30 right up here for log base 10 of 2, and we're taking half of 0.30, which is 0.15. On the next one, I'll leave those up there, log base 10 of 20 over 9. This is a quotient, so it's going to be the log base 10 of 20 minus log base 10 of 9, which is what is written right here. Now, log base 10 of 20 is really the log base 10 of 2 times 10. Split this up because now I can write this as log base 10 of 2, log base 10 of 10 as this sum, because this is a product, so this splits this up into a sum. Then minus log base 10 of 9. Well, the green one, log base 10 of 2, and the orange one, log base 10 of 9, are our two numbers that were given to us in the directions. Log base 10 of 10 just says 10 raised to what power is equal to 10? Well, any log base b of b is equal to 1, because 10 raised to the first over here is 1. So now we have to substitute in the 0.30 for the log base 10 of 2, 1 for log base 10 of 10, 0.95, the minus 0.95 because we're subtracting this one, and then just evaluate this decimal, and that's all there is to that. Now, on problem 21 and 25 in this section is what they want you to do is they want you to take this split up log, as it's split up into a sum and put it as the log of a single expression. So you know you're going to have 5, whenever you have a number out front, that's going to be your exponent, come in as your exponent to this one. So you're going to have the same base, log base 4 of p to the 5th plus log base 4 of q, means p to the 5th and q are going to be multiplied together because you're adding these two logs. So you can put these together as one log, log base 4 of p to the 5th q. On this one, log base 2 of m plus implies that we're going to be multiplying these two, m and n, log base 2 of n, plus 3. Well, what is 3 in a logarithm? 3 is equal to the log base 2 of 8. So, because that's the log base 2 of 8, I have 8, which is being multiplied by the n, and then by the m. So I have the log base 2 of 8mn. And in problem 29, in this case, we have 2 times log base 10 of 5 plus log base 10 of 4. So what they're going to do is you're going to take these two logs, and 5 is being multiplied by 4, but 5 has to be squared first. So it's log base 10 of 5 squared times 4, okay, by your logarithm laws, which is the log base 10 of 5 squared is 25 times 4 is 100. 10 raised to what power is 100? 2. So 2 is the answer. Okay, and then this one, log base 4 of 40 minus log base 4 of 5 means 40 is going to be divided by 5. So, and there's no numbers out in front, so it's just log base 4 of 40 over 5 right here, and that is equal to the log base 4 of 8. Well, log base 4 of 8, if you take a look at this, says 4 to what power is equal to 8. So over here in this section, I've actually done a side to figure out what log base 4 of 8 is, that you set up a separate equation. 4 to the x is equal to 8. And then you have 4 is really 2 squared, so you have 2 to the 2x, 2 squared to the x, okay, is equal to, put the 8 in powers of 2, which is 2 to the 3rd. And now you have same bases. You can set your exponents alike, equal. So 2x is equal to 3. And then finally, x is equal to 3 halves. So now you know that 4 is being raised to the 3 halves to get 8.